In this video, we're going to discuss control flow and how it relates to C#. We're going to cover several topics to show how to use control flow in a couple different situations. We're first going to discuss if-else statements, then we're going to talk about complex conditions, nested statements, and finally, switch statements. So what is control flow and what am I talking about here? And it boils down to, we just want to control the flow of our program. Up to this point, our code has run one line after another from start to finish. And this is a very rudimentary way of coding, and it's not going to get us very complex programs. You can't really code video games just going from top to bottom. So what if you want parts of the code to only run when certain conditions are met? For example, if a user clicks on a folder, the folder opens. We don't just constantly have those folders opening over and over again. We only have that happen when a condition is met. We can use control flow to tell the computer how code should be executed in different scenarios. So the most basic type of control flow statement that you can use is called an if statement. And you can just use this by itself. And we can kind of talk about this just using common English language to figure out what's happening. So the way that it works is you have a condition, and if that condition is true, you're going to execute specific lines of code. And if the condition is not true, we just don't run the code that's between the curly braces. So for instance, if you were talking to someone and you tell them like, hey, if it's raining, I'm going to bring my umbrella. So if it's not raining, you're not going to bring your umbrella because there's no reason to. Same thing with if statements. You think about things you want to check to see if they're true, such as if a number is a certain amount, if you're playing your game, if you have some specific type of input, you want to execute a certain code. And if that is not true, we don't want to execute that code. It wouldn't make sense to bring your umbrella if it's not going to rain. So as an example, if we have a bool that is set to true, and we are going to call that variable is playing because we're giving it a name that makes sense for what we're trying to test for. So if playing is true, so if the game is running, we're going to print to the console that the game is running. So if, somewhere else in our code, if we die, we might have is playing set to false. If we run through this if statement again, it will not print the game is running. If-else statements bring a little bit more complexity to it, and you don't have to have an if-else statement, but you can always just stick with if statements. You don't have to always have an else to go with it. But there are lots of instances where if something isn't true, you want to have specific code run after it checks to see if the condition is true. So the way that this is set up is you first check to see if a condition is true, and if it is, we can execute some specific code. If that is not true, we execute some other code instead. So for instance, let's go back to our umbrella example. If it's raining, bring an umbrella. Otherwise, bring your sunglasses. So you're either taking an umbrella or you're taking your sunglasses. It's one or the other. As an example with how this would work in code, we could say we still have that bool for is playing is equal to true. And if we are playing, print to the console that we're playing. We print out that the game is running. If this is not true, that means we're not playing the game, so we can print out to the console that the game is over. So it's either one or the other. And the thing with if-else statements is you will get either this code or this code. Like, it will never just pass through. So you do want to make sure that you are, when you're using these, the if-else, that you do want that to happen where it's either one block of code runs or the other block of code runs, depending on if something is true. We can add a little bit more complexity to this by having an if, else statement, where we're kind of checking things. We're checking multiple things where we don't just necessarily have one if statement, and we kind of want to find, like where our condition falls in this. So we're going to check to see if a condition is true, and if it is, run this code, and then we're done with this whole entire statement. It doesn't keep going. It finds the end down here and continues on with our code. If it's not true, we come down here, else if, and then it checks to see if another condition is true. If that condition is true, it executes this line of code. If it's not true, it goes down to the else. So if this condition is not true, if this condition is not true, we'll just execute this line of code and then keep going. One of the best ways to describe how if-else statements work is the experience that everybody has had where you're trying to decide with a group of friends what to eat for lunch. So you would kind of go through all your various options. Do you want pizza? Yeah. If you want pizza, then everyone goes out for pizza. You don't want pizza? Do you want burgers? Yeah, everyone wants burgers. You go out for burgers. You don't want burgers? Would you like sushi instead? Yeah, okay. Everyone then goes out for sushi. If they don't want burgers, they don't want pizza, they want sushi, fine. I'm just going to eat my lunch that I brought. So this would be like our else at the bottom, where if none of this happens, we do our last. So if no one can decide, you just eat the lunch you brought. Same thing with if-else statements. If you don't want this, you don't want this, you don't want this, we end up with this. But the big thing about this too is if you do end up with pizza, you go out for pizza. You never hit any of these statements because we're just going to execute the code in here, aka we're going to go out for pizza. So there's no reason to go out for burgers or sushi or eat your lunch. So while the lunch example is great for kind of explaining if-else statements, it's not code. So what do we usually use in if-else statements to figure out various things? Like we can use the bools as shown in the examples previously, or we can compare numbers using comparison operators. So this is kind of a review of the various ones that you can use and how you would type them out. So some of these might be a little bit different than what you're used to. So we have less than, which means, if one number is less than the other. Greater than, if the first number is greater than the other. Less than or equal to, which checks to see if it's either less than or the same. Greater than or equal to, which means it's either larger than the number on the right or equal to. Equal to, which means that they are exactly the same. And I would like to note that if you are checking to see if two things are equal, you do have to use the double equal sign. So this is comparing them. If we were to accidentally use one equal sign, it would mean that we were setting one equal to the other, not comparing them. So equal to, it's always the double equal sign. We can also check for not equal to see if one number is not equal to the other. Let's take a look at these in code now to kind of show you a little bit of how you would see some if statements as well as those comparison operators. So we have an int called first num that is set to 5 and an int called second num that's set to 10. So in this first if statement, we have first num is greater than second num. So if first num is greater than second num, print out this to the console. So with our current values of first num, second num, is this going to get printed? Is 5 greater than 10? No, it's not. So we're just going to skip this whole code block completely and continue on with our code. So we're going to hit this if statement where it says first num is less than second num. Is 5 less than 10? It is less than 10. So we will print out debug.log second number is larger. So this will get printed to the console. So we could kind of, if we want to kind of show this as an if-else statement, that's, if this one do this one, if this one do this one, we could ultimately do it like this because the first number is either greater than or it's less than. So rather than two if statements, we could rewrite this to else because it's bigger or it's smaller. So if this is not true, which it is not true, we will switch and we'll print this to the console. It is, however, not taking one thing into account, and we could possibly miss getting something printed. What happens if first num is a 5 and second num is a 5? Is first num larger than second num? No, it's not. So we're going to, this is false, right? So since we have an if-else set up, it's going to print out that the second number is larger than the first number, and that's absolutely not true. So, we have to be very careful when we're setting up our control flow to make sure we're thinking of all potential possibilities. So what can we do to fix this situation? Going back to our two if statements wouldn't solve the problem because we would just have nothing printed to the console because it would have checked to see if this one was larger, it wouldn't have run. Then it would check to see if the other one was larger and it still wouldn't have run. So we can come in here and add an if else. First num is equal to second num. And if it is, I don't know why my thing is acting up like that. So, okay, sorry. So if it is, I'm sorry, else if. There we go. If these are equal, we're going to print debug.log. The numbers are equal. Another way we could have approached this would be to have 3 independent if statements where it checked if this, and then another just if statement to check for this, and then a final if statement to check to see if first num is less than second num. You're going to be encountering these a lot. I would recommend spending some time maybe practicing using all the different signs and making sure that you are aware of what happens as the result of those one way or the other. And especially, again, I'm going to emphasize equal to. It's the double equal sign. Here is another comparison example, just to kind of give you a little bit more experience with this, where if you have an age, and this one is using just a variable, but hard coding in its comparison. And you can do either or with this. So if you're 25, if your age is less than 13, print out that you are a child. So we don't fall into here. So we're going to skip this. Else if, so we're going to check this one now. If your age is less than 18, we're going to print that you are a teen, and that's not true. We're going to keep going. If your age is less than 65, so it's not this one, you're not less than 13, you're not less than 18. Are you less than 65 though? Yes, we are 25. We are less than 65. So we're going to print to the console, you are an adult, and then we're going to get out of this whole if else statement and keep going. We're going to skip else. If it was larger than, like, let's say it said 80, we would skip all of these, and then the last thing it would print, if none of those are true, is that we are a senior. If we had 8 as our age, it would hit this first one. It would be true. It would print out you are a child, and then skip all of this and keep on going with its code. So we can add some more complex code in our if statements by using logical operators. And these are so that you can make multiple conditional statements in one if statement. So, for example, we can test to see if two things are true. So we would use the and. An example would be let's go back to going out of the house. You could say, is it not raining? And if it's daytime. So if both those are true, we're going to take our sunglasses. Maybe a better example, so we're not using a not, would be, is it sunny? True. Is it daytime? True. I guess it would have to be sunny if it's daytime, but you would want both of those to be true in order to take your sunglasses. The or operator works where only one needs to be true. Both can be true, but as long as both of them aren't false. An example of this would be, going back to weather, is it raining or is it snowing? If one of those are true, we're going to put on a hat. Both of them could be true. It could be doing both at the same time. I've seen that happen, and that's fine. But if it is raining and snowing, we definitely want to wear a hat. If it's just raining, we're going to still wear a hat. And if it's just snowing, we're still going to wear a hat. The other useful thing that we can add as a logical operator is the not. So not true. So it's a little bit different where we're not stringing two things together, but it's more of if something is not true, we're going to do something, like to kind of flip it. So if it's not daytime, we know it's nighttime, kind of the thing. So like, or if it's not night, we know it's day. And you don't forget about this operator. It can be really handy to see if things aren't true, especially when it comes to games and stuff like that. So as an example in code, what if we have a temperature of 75, we're storing that in an int, and a bool variable called precipitation when we're setting it to true. So in plain English, if we have a temperature of 75 and we have precipitation, that means it's pretty nice outside and it's raining, right? So let's kind of work our way through these if statements. So if the temperature is less than or equal to 32, so that means it's below the freezing point, and it is precipitating outside. So what happens when we have a low temp like that and there's precipitation? That means it is snowing. Else if that temp is less than 32, so it's pretty cold, and not precipitation. So we are not having anything falling from the sky. That means it's cold, but there's no snow. What if the temperature is greater than 60 and the temperature is less than 80. So somewhere between like, maybe, like a 75, hence what we're having right now. So, not too cold, not too hot. And there's no precipitation. What happens, if that's what the weather is? That means we're having a nice day. So we're going to print that out. So what happens if the temperature is either greater than 80, maybe it's less than 60, maybe it's in that range, but we have precipitation. Maybe, it's hot, maybe it's really hot, maybe it's cold, all that stuff. We wouldn't hit this. We got our snowing and cold, but if it's 100 degrees and raining, we're not having a nice day. Even if it's just 100 degrees, we're still probably not having a nice day. So we can start to make some much more complex control flow by adding if, else statements and adding in the ands and the ors to this. So I do want to talk a little bit about nesting statements, because this can be another way to make complex control flows, is that you can nest if-else statements inside of if-else statements. This can sometimes be called a decision tree as well. The best way to kind of think of this is almost like a hallway with doors that lead to more doors. So if you go through one door, you're then given a choice of other doors. And you can also use these in combination with logical operators to give you a lot of control over the flow of your code. I want to go back to the example of choosing what to eat, because this is another great way to illustrate these kind of control flows. So with this example, let's ultimately say that we want to eat pizza. Like we had our big list of like, if this, if this, if this. We decide on pizza. Okay. What about that pizza? What kind of pizza? We can add a nested if-else statement inside of there to decide exactly what kind of pizza. Because if we're going to share it, we need to make those decisions. Do we want pepperoni? So we want pizza. Do we want pepperoni pizza? Yeah. We're going to then eat pepperoni pizza. You don't want pepperoni pizza? Do you just want cheese pizza? Yeah? Okay. We'll just eat cheese pizza. So it gives you even more granular control over that information. And we can run more precise code based off of the information that we're feeding through our if statement. I would like to note, with the way that this one is set up, if we ultimately decide we don't want pepperoni, we don't want cheese pizza, this code would just finish running. We wouldn't eat any pizza. If we can't come to a decision of one of these, I guess I could have that else statement down here with the brown bag lunch again to say, hey, if we can't make a decision, we're just going to eat the lunch that we brought. So an example of what this would look like in code. So let's say we have a string variable called weapon type, and we set that equal to sword. So we have, we could print out the word sword. And we have this bool variable called weapon equipped, and we set that equal to true. So we can print out different we have this statement here, and we can print out different things to the console based on our weapon type and if we have a weapon equipped. So if we do have a weapon equipped, we're going to go in here and work with these other things to kind of determine exactly what we have equipped. If we don't have a weapon equipped, like if that's false, we're just going to print to the console that fists aren't going to work against armor. So we either have a weapon in our hand or we don't. What weapon do we have in our hand? Well, let's figure that out with a nested statement. If the weapon is a sword, we're going to print, for the queen, because we're going to raise that sword in the air and wave it around. If it's not a sword, do we have a spear? Yeah? then we're going to print charge because we're going to charge forward with that sphere. So in our case right here, since we have a sword and it is equipped, we're going to print to the console for the queen. The last type of control flow statement we're going to talk about is a switch statement. And these are very useful in very specific situations. So if you do end up finding that you're using if-else if statements, like you're having one really super long block of them where you're just checking the same variable or value over like in all of them, and it's getting really long, it might be better to use this in a switch statement instead of a giant if-else block. And it allows you to write out actions for each of those possible outcomes that you need to take into account. So it's kind of like a nice, simpler way to write a giant if-else if, etc. block. The syntax of it is a little bit different. It's called a switch statement. So we would first write the word switch, then we have parentheses, and we have what are we looking at? What variable are we trying to look at? Is it a number? So in some of the examples I've been using, like that first num, we would put switch first num in here. We can use a lot of different data types in here. It's not necessarily just an integer. It would have to be an integer. You really can't use floats with switches. That wouldn't work very well. You can use chars. You can even use strings in C# in this way. So we have switch in our parentheses. We say what variable are we looking at? What are we checking here? And then we have our open and close parentheses, and between those we have our cases. So we write case, and then what value. So if we have a number, we could have like we could write case 1, the colons, and then our execute code. So if it's equal to 1, what do we do? And it'll run the code, and then you always write break afterwards so that it doesn't fall through to the next one. Because if we forget the break in here, we're going to keep executing code until we hit 1. So we can have our first value, our second value, and we can have as many values as we need. And then we should always have a default case at the end. The default case is kind of like our else. So if this isn't true, if this isn't true, if this isn't true, if this isn't true, this runs no matter what. I always like to keep a default, even if maybe I only have 3 things and it should only be those 3 different things. I usually kind of keep a default that even if it's not ever supposed to run, maybe it might throw an error to my console, because I know if I get to there, then something happened elsewhere in my code, because I should never see my default. But you can always use the default. Like, you don't have to use it in that way. Maybe you do have a default condition that if nothing else is true, always do this. So what does this actually look like in code? Let's kind of use the example of maybe we want to print out a statement to the console based on somebody's grade. So we're going to use a char called grade, and we're going to just set this example to B. So the way that this works is we write switch, and in parentheses, what variable are we checking? We're checking grade, so we put grade into here. We then have our open and close curly braces, and then inside of here is where we write all of our cases. So if we have a case where grade is equal to A, what do? We have the colons, and then we have our code. We're just going to print to the console debug.log that it's perfect. and then we break, which means we're done with the switch and we forget the rest and we keep going. I would like to note that even though these are single lines of code, you can have multiple lines of code in here. You can have, if you really needed to, you could have if statements in here. You don't want to make these too complex though, because it might start to get a little bit messy, get a little bit confusing. But do keep in mind that you aren't just limited to the one line of code. You could hit enter and add more code to this. So if it's case A, print out that you're perfect. If we had a B, we would say, hey, that's pretty good, good effort. If we had a C, we're going to print that you met the expectations. If we had a D, we're going to, try to give a nice encouraging message of try harder next time. But if it's not an A, a B, a C, or a D, you failed. So we're just going to print that you failed to the console and be done with it. So in this case, if we have a B, it's going to check this. Nope. It's going to hit here. Yes, it's true. This is correct. So we're going to print good effort. We're going to hit break and we're going to go out of the switch statement. If this was an A, we would hit the first one, print this, hit the break. This breaks us out of the switch statement. If we have an F, we would go through, go through, go through, go through. We would hit this, print you failed because it's the default because none of those are true, and break. What if we sent a Q? If we had Q, we're still going to print you failed. So, kind of keep that in mind, that if you don't mind that kind of result, that's fine. But the default will catch everything else. So even if we are feeding it things that aren't like a character that's not normally a grade, it will always print you failed at the end. So it's not A, B, C, or D. So that's it as far as our stuff goes. We did talk a little bit about if-else statements. Remember, this is kind of like trying to decide what restaurant to go to for your lunch. We talked a little bit about complex conditionals. These are the ones, for instance, like you're trying to figure out what to wear out of the house. Is it sunny and is it daytime, or is it cold and is it precipitating? Determines what the weather is outside. The nested statements are like, again, eating out, where you chose the restaurant you went to, but you're trying to get a much more precise food that you all can share by, do you want pizza? Yes. Do you want pepperoni on that pizza, or do you want cheese on that pizza? So that you know exactly what you're getting. You can have it a little bit more specific. And last, we talked about switch statements, which are meant for checking on single variables for very specific values. So for instance, if you have your grades, you would have only A, B, C, D, or F. So I would recommend that you kind of, if you need to watch this again, I know this is getting a little bit more complex than we've been doing, but definitely follow up with the demo video, where if you need a little bit more hands-on, we're going to work through all of these different types of things with lots of good examples.